Okay guys, so in this video we will be talking about OSPF metric, more specifically OSPF cost of a link and how we can manipulate the cost of a link and why we need to know how to change the cost of a link. And if you're wondering what I mean by OSPF metric or the OSPF cost of a link, let's focus on our network diagram right here. So we have 5 routers here, and we are using OSPF for them to communicate. Now if you go on the R4, we can test our connectivity just to make sure that we have at least connectivity to one of our routers. We can do a ping to say R1, which the IP address on R1 serial 00 interface is 1.1.1.1, and you can see we have a success rate of 100%. We can also try this with R2, which the IP address for that would be 2.2.1, and we have connectivity there. So if you do a show IP route, we can see that we have learned our 1.1 network on our 2.2 network via OSPF, and we can see that a few other information here which we're going to be focusing on today is these digits right here, which would be our metric. The 110 right here would be referring to our OSPF administrative distance, and the administrative distance for OSPF would be 110 or 110 in this case. So some of you guys might be wondering, well, what is the metric? The metric is basically what OSPF calculates to choose the best path to a network. So I'm over here on R4. As you can see, the metric right to get to our 1.1.1 network is 65, and how it calculates the metric or the cost to get to that route, it looks a little bit like this. If you look on our notepad right here, we can see the formula for calculating, or the formula that SPF uses to calculate the metric or the cost to a route, is the reference bandwidth divided by the interface bandwidth. Now the reference bandwidth by default is 100,000 kilobits, and that is hard-coded into our iOS or our router that the router uses, and that is divided by the interface bandwidth. Now the interface bandwidth is the speed of the link that is being used on a specific interface, and we can check this. Let's proceed. We're going to check our serial link right here. Let's head over to R1 and we go to our command line interface, enable mode. We can check our bandwidth by doing a show interface serial 0/0, and we can see right here we have a bandwidth of 1,544 kilobits per second. We can also confirm the bandwidth for R2 as well, doing a show interface Ethernet 1/0, and we can see we have a bandwidth of 10,000 kilobits per second, which is also 10 megabits per second. Now if we head back over to our notepad and let's say we want to calculate the OSPF metric or the OSPF cost for this link, it would be 100,000 the reference bandwidth divided, the default reference bandwidth I should say, divided by the serial interface bandwidth, which would be 1,544 kilobits per second, which you could see here that would be equal to 64 kilobits per second. Now it would be the same for the Ethernet. The cost for the OSPF would be 10, and for fastethernet would be 1. So Ethernet would be 100,000 kilobits to reference bandwidth divided by 10,000, which we confirmed earlier from our show interface command. Now for the fast Ethernet, let's go into R3, and we have our fast Ethernet link right here. Let's confirm the speed for that link. So we do a show interface F0/0, and we can see the bandwidth here is 100,000, so it is 100,000 divided by 100,000, which would be equal to 1. And let's head over to our gigabit Ethernet, and it's going to be our reference bandwidth divided by, and let's check to see what our reference, let's check to see what the bandwidth for a gig interface is. So we do a show interface gig 0/0, and we can see our bandwidth right here. It seems to be 1,000,000 kilobits per second. Now the interesting thing about Ospf is that once it starts to calculate a number that is higher than our numerator, once the denominator is higher than the numerator, that link is gonna automatically equal to 1, and we can confirm this by going back to our R4 and we do another show IP route, and what we're looking for is the route back to R1, which is here on that network, and we can see that the Ospf cost for that link is 65, and how we get that is the Ospf cost for a serial link is 64 plus our gigabit link right here would be 1, so 64 plus 1 would equal to 65. So we can confirm that it is calculating this link as being 1, which comes to an important session which we need to discuss in terms of if we had a fast Ethernet link and a gigabit Ethernet link to, say, a router on our network, we would want our Ospf network, converged network, to be going over our gigabit Ethernet link. We would not want it to be going over the fast Ethernet link because it's slower. So it is important that we learn how to manipulate the Ospf cost, the reference cost, or should I say the reference bandwidth, and also how to manipulate the bandwidth of our interface itself. Now there are two ways that I will show you today that you can change the actual Ospf cost of a link and also change the bandwidth of a link. Now our first method includes interface command. Let's use fast Ethernet per se. So we go to fast Ethernet, and first let's do a show IP route on here, and we will use our example saying going to R4 to be a 4.0 network, and we can see that the Ospf cost is at 2, which means that our fast Ethernet link Ospf cost is 1 and our gig link is 1 as well, so 1 plus 1 will be equal to 2. And what we're going to do, we're going to do a configure terminal. We're going to jump into interface fast Ethernet 0/0, and we're going to use the command IP Ospf cost, and then we're going to define the cost as 10. Now once I do that, it might take a little while, but this Ospf cost should change to 11. So if I do a show IP route Ospf, we have to do a do command, do show IP route Ospf, we can see that the Ospf cost has changed to 11. So the cost for this link right here from this interface would be 10, and plus the cost of this interface, which is 1, the default 1, and then we would get E11. 10 plus 1 is equal to 11. Now the rule of thumb, Cisco recommends that whatever you do on one interface, you do it on the other interface. Reason being, if I head over to R4 and I would check the cost to get to R3 from R4, the cost would not change, it would still be a 2, and we can confirm this by doing a show IP route Ospf, and we can see that the route for our 3.3 network is still 2. So what we have to do, we have to go to the other side of our router or edge router, and we do a configure terminal, and we're going to jump into our fast Ethernet 1/0 interface, and we do a IP Ospf cost, and we're going to call that 10. Now once we do that, we can head back to R4 and we can do another show IP route. It hasn't changed yet, takes a little while. Let's do it again, and as you can see, it's now 11. Now that is one way of how we can change how OSPF chooses its path. Now that if OSPF were to choose between our R4 link and our R3 link, OSPF would choose our R4 link. Or per se, if we had two links and we configured one with an OSPF cost of 10 and we had another OSPF cost of a default 1, it would definitely go over the OSPF cost of 1 because it has a higher bandwidth, and also because we configured the link to have a higher cost. And OSPF would definitely choose, if it choosing the cost of 1, that would mean that it has a higher bandwidth. But it's like we're checking our routers to say that it has a higher cost. Now the other way that we can tell our routers that we need to choose the better path, or the path with the more bandwidth, is that we can actually change our reference bandwidth. If we change our reference bandwidth, automatically we wouldn't have to change any of our interface bandwidth or the cost itself. So if we head back to our edge router over here and we do a no IP cost and head back over to R3 and also configured our no IP cost, essentially everything should go back to normal. We do show the route. Takes a little while for our databases to be shared again. As you can see, we're back at the cost of 2. So what we're going to do now, and the next steps, when we do make this configuration, our next configurations, once we do it on one router, it is recommended by Cisco to do it on all other routers, because we want all our routers to be using the same reference bandwidth, to be the same, so that when they start exchanging the databases, we don't have any confusion or any odd numbers within our IP route. So let's jump into our router OSPF1, and we're going to set our reference bandwidth. So the configuration goes as auto cost reference bandwidth, and we're going to use 1000 megabits. Now if we do a question mark here, we can see that the reference bandwidth in terms of megabits per second, not kilobits per second, megabits per second. So Cisco also recommends that we use the auto reference bandwidth as the highest bandwidth that we have on our network, and since we have a gig link, the number for that would translate to 1000 megabits, because 1000 megabits is equal to 1 gigabit. So once we do this on one router, you're going to get a message saying to our command line saying reference bandwidth is changed. Please ensure reference bandwidth is consistent across all routers, which is what we're going to do right now. So we're going to copy this command. We're going to head over to our edge router. We're going to jump into router config mode, and we're going to paste that command, and we're going to do that for R4 as well. So we're going to do a show. Now we're going to do a configure terminal router OSPF1, and let's paste that there as well. So let's do a show IP route from R3. Let's see what our cost is to R4. So do a show IP route OSPF, and as you can see, the cost is now 11. So once we change our reference bandwidth, we can see that it's actually now configuring it's choosing the best path, or I should say it is calculating it as how we would want it to if we were in a real world situation. Now another thing to note is that if we did not do this change, essentially if we had a fastethernet gig ethernet, it could also be causing a load balancing situation. So in case we have a fast Ethernet link and a gigabit Ethernet link, this would be causing, it could not per se 100%, but it could be a case where it starts doing a load balancing, because that's also another feature of OSPF right there. If the links have the same cost, it will, or it could do load balancing in some cases. And that's it for today.